Hello friends, welcome to another tutorial in digital signal processing. We'll do convolution of discrete time signals today. The basic definition is here on the screen. Convolution is used to compute output of an LTI system given the input is there, x of n, and the impulse response of the system, h of n, is there. Now you need to be conversant with the definition of h of n. So it is going to be the response of the system. You'll get h of n at the output of some system. Let us say this system is x if it is subjected to impulse input, unit impulse input. So h of n is obtained by a system when impulse is given as input. So you need to be aware of the definition of the convolution, and you could check out previous videos for that. Convolution is only applicable to LTI systems, so you need to be aware of what LTI systems are. But here in this case we'll be given with x of n, which will be the input for which we wish to calculate the output if the impulse response of that system is known. So let's begin with the computation process. We see that in a typical question of convolution for discrete time signals, we'll have x of n. So x of n is a signal which has 4 samples here. So x of n has 4 samples. At 0 it is 1, and this is 2, this is 3, and this is 4. And h of n, which is the impulse response of the same system, is 0 for 0 sample. At sample number 1 its value is 2, 2, and 2. By the way, this is the scale I'm following. This one block represents 1, so it is pretty elementary. And the basic definition of the output by convolution, this is the sign of convolution, is that summation of k from minus infinity to infinity, h of k into x of n minus k, or vice versa, x of k h of n minus k, because of the commutative nature of convolution. Because convolution is commutative in nature, so we could either use h of k x of n minus k or x of k h of n minus k. We'll see that in a bit. So when we have such a question, we need to find y of n. So how do we do that? Our first step is to convert this x of n into k, which is very easy. You simply replace this with k, and because this axis was n earlier, so you will say this is k axis. So that's about it. So everything that you see on the nth samples are now on the kth samples. And the next step is to find h of minus k, and then we'll see the values of shifted h of minus k. So for that we draw h of minus n, which is this, and if we say that this is h of k, we can say this is h of k, and then h of minus k will be an inverted image, a mirror image. So what we have on the k axis will now be appearing on the minus k axis. So this is time flip signal. And by the way, h of minus k is also h of 0 minus k, so you're not shifting the signal once you have inverted this. However, when you shift the signal by +1, so this signal shifts towards right, and whatever was there on -1 has gotten shifted to 0. So this is h of 1 minus k, or minus k plus 1. So everything has got shifted to one place towards right. So what we need to do here is we need to draw, because for y is equal to 0, this will be the value of h. At y is equal to 1, this will be the value of h. And similarly we need to see for all possible values of y. And we can draw as many values of h for as many number of n's, but in a bit I'll show you we do not need to draw all the values of h for all the values of n, because eventually we would need to find out the multiplication of this blue signal with the red signal, and eventually we need to sum this up. So if we look the first blue signal and the red signal, we do not have any values that are common, or in other words overlapping. So if we multiply this red with this blue, everything will get to 0, because on -1, -2, -3 this red signal is 0, which will make all these values 0, and from 0 onwards this blue signal is 0, which will make the values in the red signal 0. And the red signal is our x of n. The blue signal is a representative of h of n minus k. So if we do not have any value obtained after multiplication, we cannot really add any of them, so the sum total will be 0 here. But if we multiply this blue with this red, now we have one sample which has non-zero values. So add sample number 0, blue is 2 and red is 1, so 2 into 1 will be 2, and rest everything will vanish away. This will become 0 courtesy this red signal, and this all will become 0 courtesy this blue signal. But as we shift the signal towards right hand side, more and more samples will overlap, and we can get non-zero values of the samples, and we can simply add them up. So what we have here is, I've drawn the values of h of 2 minus k, 3 minus k, 4 minus k, 5 minus k, 6 minus k, 7 minus k. The reason I've taken this to all the way to 7 minus k, because at 7 we do not have any overlapping signals, because this has gotten away from the domain of the red signal. Red signal was only present up to sample number 3, and this signal has now been shifted after sample number 3 to sample number 4. The first sample appears at 4, so everything will become 0 here. So this need not be considered in the convolution process. But up to this point we'll have some overlapping signals, because at this point at +3 we have the value 2, and at 3 we have the value 4. So 3 into 4 we can get a value 12. So that's how you compute. For y is equal to 1, we have just 2, which is at sample number 0, and rest everything is 0, so the sum total is 2. For y is equal to 2, you can calculate for yourself that it is 2, which is at sample number 0, then we have 2 into 2, 4, then all zeros. So 2 plus 4 is 6 summation, as suggested by the convolution theorem. And y is equal to 3 is 2 here, 4 here, 6 here, multiplication of this blue with this red, and the magnitudes of the blue signals are multiplied by the magnitudes of the red signal, and this will make sample number 3 0, and all the things on the left hand side will also be 0. So that's how you can calculate or compute y of 4, which is 18, y of 5, which is 14, y of 6, which is 8, and y of 7, which is 0. So finally you can write the values of y of n, which is 0 at sample number 0. So the output at sample number 0 will be 0, output at sample number 1 will be 2, and so on and so forth. So you get 0, 2, 6, 12, 18, 14, 8. So how many values do you get? You get 7 values. and there's this very famous formula to see how many values can we get at the output. If x of n has 4 samples, y of h of n has 4 samples, y of n will have 4 plus 4 minus 1 samples. So samples in x, samples in y are added, and then 1 is subtracted from them. So we've gotten our answer correct. And another method of calculation which is known to be a shortcut method is this method. I'm gonna illustrate now. So x of n can be written like this. If no arrow is specified, we automatically assume that this starts at sample number 0. This is also starting at sample number 0. So I write down the values of x of n along this axis and h of n along this axis. So what I have here is okay. Now what I do is I take this value of h of n, the first value, and I'll multiply all of these with the first value of h of n and write the solution here. So 0 multiplied by 1 is 0, 0, 0 and 0. The first row is obtained by multiplying the first element with all these elements, and the second element is 2. So I multiply 2 with all these elements and write the answer here. 2 into 1 is 2, 2 into 4 is 4, 2 into 3 is 6, and then 8. And similarly you can populate this entire table like this, and then we need to draw diagonal lines like these. And when you draw these diagonal lines, you need to simply add the elements in these diagonal separations. For example, this diagonal has just 0 here, so this diagonal has 0 plus 2, 2, and sum them up. See, 2 plus 4 plus 0 is 6, then 2 plus 4 is 6, 6 plus 6 is 12, and then 4 plus 6 is 10, 10 plus 8 is 18, and so on. So you can easily calculate the values of y of n, which is similar to the value that we calculated using the convolution theorem's formula. So this is a shortcut method. We can do more questions on this method. If you wish, you can comment down below if you wish me to solve more questions like this. And the total number of samples in y of n is of course samples of x of n plus samples of h of n minus 1. Now there's one question for you that I wish you to ponder about. If the values of x of n are starting from here, so if this sample is the 0th sample, this is minus 1, this is minus 2, and if the value of h of n is starting from here, this is the 0th sample, this is minus 1, these are 1 and 2, then how would you label the samples here? Because this was a typical case where both x of n and h of n were starting from origin, so we started y of n from origin also. But what will happen if x of n and h of n are not starting from origin? So I'll answer that question in later videos, and just comment in the comment section if you wish me to do more numericals on this. If you liked the video, give it a thumbs up. That's it for today. I'll see you around. Take care. Bye bye.